Hello and welcome to last lecture in our Numpy basic chapter in our comprehensive course on machine learning, data science and artificial intelligence. Now, in this lecture, as such we were seeing various different examples of Numpy array and how to slice and index Numpy array. But now one step more, that how to do conditional operations on Numpy array. So let us first create a simple Numpy array np.arange 10. We have already seen about arange function. So when you write 10, that means it will create an array not including 10, but all elements up to 10. Beginning is not specified, so it would be 0. And step size is also not specified, so the default step size would be taken. That would be 1. So let us see what this output is. 0, 1, 2, 3, 4 up to 9. Okay. So starting from 0 to 10, but not including 10, all elements they are created. Fine. In this array. Now suppose someone says that create an array which is having only elements greater than 5, then will I define a new array or will I want to reuse the same array? Then I can reuse the same array. I can use the conditional array, and in bracket, in a square bracket, I can specify the condition that conditional array greater than 5. That means take only those elements of conditional array which are greater than 5, and then we will print them. If you see, then you will get only 6, 7, 8 and 9. So that means these elements which are greater than 5. Okay, and this is pretty handy sometimes, because in one line of code only you can get directly the elements based on any condition which you specify here. Okay, fine. Now you can specify another condition also, that a conditional array less than 5. So in that case it will print 0, 1, 2, 3, 4. Okay, so that is how it is. Now one more thing is about this. This is the most important application of Numpy array as far as data science is concerned and mathematics is concerned. We can find dot product using Numpy array. And when our actual data science chapters will start, and we'll start with linear regression and logistic regression and all, you will see that in the very first initial discussion only dot product will be required. What is dot product? For that, first let us understand what is a vector. Then this, what you used to call a Numpy array, that is itself a vector. So a vector is nothing but mathematically an n-member vector is shown in this manner, even a2 up to n. Some books also write this as n-dimensional vector, but then it creates that confusion that between whether it is a 2D array or 3D array. No, this is not 3D array or ND array. This is just one-dimensional. As far as Numpy array is concerned, this is a 1D array. But it has how many members? So it has n members. So I will prefer to use n-member vector. For example, this is a 3-member vector, and this is another 3-member vector, like that. Okay. So vector is just a new word, but actually it is not a new thing for us. A vector is nothing but Numpy array, one-dimensional Numpy array. Now, how to define dot product for such one-dimensional Numpy arrays, or for which now I have got a new word, and therefore I can write vectors. So these are two vectors, and I want to find their dot product. Then dot product is, this sentence is important, sum of products of corresponding elements. So first do this, products of corresponding elements, and whatever answers are obtained between those, you write the plus sign. So here what is the meaning? This is the first element multiplied with this first element. So 1 multiplied by 11. Okay. Then do second element multiplied by here second element. So 2 multiplied by 45. Then third element multiplied by this third element. So 3 multiplied by 33. Not 33 actually, 53. Okay. And then once all those products are obtained, this says that sum of products. So in between the product terms, you take the plus sign. Okay. And if you add them, then you will get 200. Let us check that code wise. Okay. Because Numpy saves you of this trouble, that take first element and multiply, and then take second element, multiply with second element of these. Otherwise you can check, this would be 45 into 90, this would be 53 into 3, that means 159. So 159 and this would be 11. So that means 159 and 11 is 160, and this is 90. So answer would be 250, I think. Okay. Let us write here, and these are different two vectors, but let me change. I want to check my answer. Then 1, 2, 3 and 11. Okay, no, this is the case of two-dimensional vectors. I will keep it as it is. But first, let me just take one extra, and a equals np.array inside parenthesis bracket, and there you can write 1, 2, 3, 1, 2, 3, and b equals np.array, and in bracket you can write 11, 45, 33. Okay, and then write a dot b. there is no need to manually calculate NP dot you have to use NP dot 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 product A comma B. Okay, so there is no need to do all these things. You will get the same answer. 200, 45, and originally it was 200. I changed it, and okay, this is 33 only. Why I changed it? Here I should have changed it 33. Fine. So 33 into 3, 99, 99 and 11. So that is 110, 110 and 90. So that is 200. Correct. Okay, fine. So that is what it is. And if I make this 53, then I will get that 250, 260. Yeah. Okay, fine. No problem. So you can get dot product directly by NP dot dot. NP this dot, and then function is also named dot dot. Okay. Now for 1D it is still a little bit easier, but for 2D arrays you will see that how efficient Numpy makes the things for you if you manually try to calculate dot product. For example, let us first create a 2D array. You can check it that this is a list of list. This is one inner list which will become the 0th row, and this will become the first row. So it is a 2 by 2 matrix will be created. Okay, and then this is also list of list. Inner two lists are these, and outer also two more square brackets. And let us see what A and B are. Then A is 1, 2, 3, 4, and B is 2, 0, 1, 2. Now if I want to do my dot product by my standard method, and I'm teaching this because at least once in the life one should know how to do dot product. Then first you have to remember that dot product is not always possible. It is only possible when the number of columns in the first vector, first array or matrix is equal to the number of rows in the second matrix. Now here it is 2 by 2 and 2 by 2. So number of columns in the first is 2 and number of rows in the second is also 2. So fine. So that means dot product is possible. And whenever that dot product is possible, what will be the answer dimension? Then whatever is common, that mentally you cancel, and whatever is left, that is the dimension of your resultant matrix. So it will also be 2 by 2. Now how to get this? Then you have to first think what I will put here. So I want to put something here. Okay, but what is this? Similarly, I want to put something here. Okay, something here. I want to create a 2 by 2 matrix. So what is that something? So you have to think which dimension this particular is, red dot. So it is 0th row and 0th column, okay, of resultant matrix. So you have to take 0th row of your original first matrix and multiply corresponding elements with 0th column of your second matrix and do the sum of products. So 1 multiplied by 2, 2, and 2 multiplied by 1, that is also 2. So what will come here? It will be 4. Okay, fine. Then here, now this is 0th row, but first column. So take 0th row, but this time don't take first column, 0th column, but rather take this green. So one blue and one green I am taking. So 1 multiplied by 0, 0, and 2 multiplied by 2, 4. Okay, and sum of those all products. So 0 plus 4, so that will also be 4. Fine. Okay. Then I want to find these elements. So it is first row and 0th column. So take the first row, this row, and take the 0th column. So one green row and blue column. So 3 multiplied by and corresponding elements product, and then find the sum of products. So 3 multiplied by 2, 6, 4 multiplied by 1, 4, and 6 plus 4. So that is 10. So here the answer will be 10. Okay, this is 10. Similarly here, for example, then this is actually for the resultant matrix. This is first row and first column. So then from the first matrix, take the first row. First row means this green, and take the first column from the other one. So green. So green, and corresponding elements product, and then the sum of products. So 3 multiplied by 0, 0, and 4 multiplied by 2, that is 8. So this is now like this, 8. Okay. So 4, 4, 10, 8. Now let us see. Every time this dot product getting this way is a tedious business. 4, 4, 10, 8 we can directly get by just one line of code, np dot dot, and A and B we have obtained. So then you can see 4, 4, and below that 10, 8. I told you that mentally shift this below exactly for better visualization. So 4, 4, 10, 8 is obtained. Same is the case here. That is now for this kind of case. 1, 2, 3, 4, 5, 6 is one matrix. Forget about this sign bracket. It should be square, and this also. And this is 2 by 3, and this is 3 by 2. So it satisfies the condition. Number of rows in first is 2, but number of columns in first is 3, and number of rows in second is also 3. So the condition is that number of columns in the first matrix and number of rows in the second matrix, they must be equal for dot product to be defined. So how dot product you will do? Now you can do this way, that if I want how much first this condition is satisfied because number of columns are here and number of rows are here equal. So whatever is equal, you cancel that mentally, and whatever is left, that will be the dimension of resultant matrix. So resultant matrix will be here also 2 by 2 matrix, these two green lines, so 2 by 2 matrix. Now how to find this? And here I want to find what element will come. This is 0th and 0th position. So take 0th row of first matrix and the 0th column of second matrix, multiply the corresponding elements, and then take the sum of products. So 1 multiplied by 4, 2 multiplied by 5, and 3 multiplied by 6. So 4 plus 5 into 2, 10, so 14, and 14, and this is the 18, so it would be 32. Okay, so the element at 0th row and 0th column of the resultant matrix would be 32. Now this element I want to find, that is element at the first row, 0th row and first column. So 0th row is already green, and the first column is this blue. 0th row is red and first column is blue. So red and blue, so 1 into 7 plus 2 into 8 plus 3 into 9. That is written here. So 7 plus 16, so 23, and 23, and this is 27. So 27 and 23 means it should be 50. Okay. So this element here would be 50. Then this element here, what it will be? So it is first row and 0th column. So first row means this green row, 4, 5, 6, and 0th column is red. So green and red. So 4 4 are 16 plus 5 5 are 25 plus 6 6 are 36. So 36 plus 16 is 40, 52, and 52, and then this is 25. So 52 and 5, 57, and 20, so 77. So this would be 77. Okay, and then finally this last. So that is here element, which element will come here. Okay, this is the closing boundary of my 2 by 2 matrix. So it is first row and first column. First row means green and first column means red. So green and red. So 4 into 4. First row and first column. Okay, so that means green and blue. So 4 into 7 plus 5 into 8 plus 6 into 9, and then sum of all those products. So 4 into 7, 28 plus 40 plus 54. So 54 plus 40 is 94. 94 and 28. So 622. 122. Okay, I am calculating orally, so there might be some mistake. Might be, but Numpy does not make mistake, and it frees us from this trouble of calculating orally. Okay, so we create the same two arrays which here are shown, 1 2 3 4 5 6. Okay, so we will create them. Dot product I will keep in the next extra cell. Okay, and just A and B two arrays let me create. Okay, and a little bit smaller in size so that you can see. Yes, so 1 2 3 4 5 6. So that is this array left side, and this is 4 5 6 and 7 8 9. That is the other one. Okay, print B is coming 2 times. That is creating issue. Okay, so 4 5 6 and 7 8 9. That is the right one. Now dot product. Then just one single code, np dot dot a comma b, and you will get the answer as 32, 50, 77, and 122. 32, 50, 77, and 122. Okay, fine. So I got the answer without even blinking my eye. Okay, so this is the Numpy basics. Remember, we want to still explore advanced functions of Numpy, and before that I urge you to do these exercises. Thank you, and see you in the next chapter, 5th chapter, advanced Numpy.